students, welcome to digital classes. This is your chemistry digital class, and today on 28th July we are going to recapitulate our laws of thermodynamic as before going to start today's topic. Although today's topic is something different, but before going to start, I wish that we will recapitulate 2 minutes that whatever we have done. So we have started our unit 6, that is thermodynamic, in which thermo mean heat and dynamic motion. So many times I told you in my every lecture I am going to tell you about the meaning of thermodynamic. Why? Because whatever topic we are studying, in that topic basic is the transfer of heat. Okay, so transfer of heat energy from one place to another is called thermodynamic, which origin came from conduction, convention and radiation. In our junior classes we studied. So law of thermodynamic is the central topic of this unit, which need to be studied with full of focus, and we need to be understand it properly. So we are going to start Zeroth Law. Already we did, in which we studied that when any two body or any two substances are like A and B are equilibrium, thermal equilibrium with each other, or second B and C is thermal equilibrium with each other, it means that A and C, whether they are not direct in equilibrium but they are also in equilibrium, so in that way the net transfer of energy is zero. That's why the law is called Zeroth Law. Whereas in first law of thermodynamics we studied that energy can neither be created nor be destroyed, only transfer from one form to another form. Okay, so mathematically, if we will say, mathematically we studied that internal, it is a change in internal energy. Okay, it is the change in first law of thermodynamics is a change in internal energy. If we will talk about the initial internal energy, that is U1, and final internal energy is U2, where internal energy is denoted with U. Okay, so the change in internal energy is what it is. U2 is equal to U1 plus, when we are going to change the internal energy, when some charges are going to pass, when some heat is absorbed by initial internal energy. Okay, initial state. And how much work is done, this is the already we have done. I'm just going to recapitulate this. Final internal energy is what? U2, when U1 is going to gain some energy, absorb some energy, and by that energy, if that system is going to do work, that is called somewhere U2 final stage. So now what stage is coming? U2 minus U1 is equal to Q plus W. So it becomes delta U is equal to Q plus W. So this is the situation that will come in front of us in first law of thermodynamics, which state that the change in energy is equal to the number of charges and work done by those charges. Okay, this is change in energy, or I can say now enthalpy change. Okay, dear students, so as we have studied in first law of thermodynamics, there is a change in internal energy by passing some external heat or energy, which is passing through with the help of Q, that is charges. Now when we are going to change the heat, or when we are going to change the internal energy or the energy of a system, which is suppose, for example, our body, as I have told yesterday, our body is most comfortable at 37 degrees Celsius, mean this is the most suitable temperature of our body. What when we are going to sit in a hot day, in a summer day, under the sunlight, so what is happening? Slowly our body is feeling hot, our body is feeling heat. Okay, that it means that our body is gaining some external heat, external energy from the surrounding. Okay, at that time the delta U is going to change, U1 is going to change U2, and it is becoming U2 depend upon how much energy and how much work done is there by body. So the situation or the system, I can say the state in which the amount of heat is required to increase the temperature from lower temperature to higher temperature, that is known as heat capacity. Okay, so yesterday we did heat capacity, so maybe it is not clear to some of the students that what is heat capacity, from where it came. Heat capacity is denoted with C. If we will going to if I will go to going to define it, it is what? It is defined as the amount of heat is now Q, okay, required to increase the temperature, required temperature of the system from lower temperature, which is T1, to higher temperature, that is T2, okay, which is divided by temperature differences T2 minus T1, okay. So I'm going to explain that again. Let us see amount of heat is Q, okay, and the temperature differences is T2 minus T1, which can be written in form of delta T. So the C is equal to Q upon delta T, or C is equal to, so then Q become C multiplied by delta T, which is called, where C is called heat coefficient here, okay. Now we can add molar heat capacity. The moment we will add molar heat capacity, which is also known as specific heat capacity, M. So molar heat capacity is what now? It is the molar heat capacity is the substance which is defined as the amount of heat required to increase the temperature of 1 mole. When we are going to take 1 mole of system, it is the amount of heat required to raise 1 mole of raise the temperature of 1 mole of system through 1 degree Celsius is called molar. So now we are going to add molarity in equation 1. So it be Q is equal to C into M into delta T. Q is equal to C into M into delta T. This is the general equation of heat capacity. Now we are going to relate the CP with CB. So there are two types of heat capacity. Number one is we have, that is CB, and number two is CP. Now what is CB? CB is at constant volume and CP is at constant pressure, okay. So in case of CB, that is QB upon delta T. Now Q upon delta T is there, so we will write now QB upon delta T in case of volume, and P upon delta T in case of pressure, okay. And QB is written as delta U upon delta T, whereas in QP will written as delta H upon delta T. Delta U is change in internal energy and delta H change in enthalpy, which we are going to do today, okay. So if we will combine both the delta U and delta T, so what we'll get delta QV is equal to CV minus CB delta T, and QP is equal to CP delta T, okay, which is equal to delta U and equal to delta H. Now you'll see, you know very well that CP is now delta H upon delta T. CB is equal to delta U upon delta T, and CP is equal to delta, again I am telling you, CV is equal to delta U upon delta T, and CP is equal to delta H upon delta T, okay. So if we will combine these two, so CP is equal to, it become delta H upon delta T, delta H upon delta T. We know that delta U upon delta T minus, delta H upon delta T minus delta U upon delta T is equal to NR, okay. This is we know already, we have explained delta H upon delta T minus delta U upon delta T is equal to NR. So in place of this we will write, so equation will become CP is equal to CB minus NR. So it becomes CP minus CB is equal to R, okay, which is the relation between that we need to find out, which is the relation between CP and CB. CP minus CB is equal to R. So now I think you are thinking like this way, ki how QB is delta U and how QP is delta H, okay, as we have done in CP and CB. So CP, CB is heat capacity. So QB and QP, or I can say CP is delta U and CP is delta H. Question is how? So for that purpose, we need to study about next topic, that is enthalpy. Enthalpy is denoted with H. So let us understand what is the meaning of enthalpy. Basically what is enthalpy? It is the energy stored within the substance or the system, I can say, because you are understanding the substance by system in this particular chapter, that is available for conversion into heat. Once again, it is the energy, if I will underline this, it is the energy that is stored within a system that is available to convert into heat. Every energy inside the body cannot convert in form of heat, but there is some external energy or there is some stored energy which can be converted in form of heat. Like we are having food, okay, once we are having meal, then we can do our work. So you know very well, the energy is what? It is the capacity to do work. Energy is what? It is capacity to do work. More the energy we have, more work we can do. Okay, so that energy which is present in our body, which is stored in our body, that is available for conversion into heat, and with the help of that heat we can do the work done. That is studied, we have studied in that first law, that is Q plus W. It is the amount of energy that is need to be used to do work. Okay, what is the enthalpy now? Basically in Greek word enthalpy mean warm up, or we are going to do that work, that heat, we are using that heat to do the work, that is called warm up, and it is also called a heat content of the substance. Okay, so enthalpy is denoted by H, and it is related to internal energy through the mathematical equation like H is equal to U plus PV. Now in here you need to focus, what is H? H is, as I said, enthalpy here. What is U here? U is internal energy that is required, and P is pressure here, and V is volume here. Okay, so what is H is equal to U plus PV? It is the enthalpy which is related to internal energy through the mathematical equation, and enthalpy is also a state function. It is also a state function. It is defined definite value depending upon the state of the system, and it is independent of the path by which the state is reached. So H can be written, delta H is equal to delta U plus P delta B plus B delta P. Okay, either P delta B or either it is B delta P. When delta B is there, it means that P is constant. When delta P is there, it means that volume is constant. Okay, so hence at constant pressure, it means that delta P is 0. Delta H become delta U plus P delta B. Okay, at this is the point. P is not changing, delta B is changing only with the change in internal energy. Thus increasing, what become the basic statement of this? It states that increase in enthalpy delta H is equal to the heat absorbed in the process at constant pressure. At constant pressure delta U, when only pressure volume work is done, when only pressure delta B, okay, is done. Okay, so hope so you understood the meaning. So it means that enthalpy is increasing when heat energy is coming inside the system. So it is a system suppose, and heat energy, enthalpy will only increase when heat energy will absorbed by system, and enthalpy will decrease when heat energy will release the system. Heat energy is released by the system. So here enthalpy, in this situation enthalpy increase of the system. In this case enthalpy decrease by the system. Okay, So long as the system does no additional work or heat supplied, at that time delta H is QP. So it is independent to path, and delta H is equal to H product minus H reactant. Okay, delta H is positive. Delta H is positive when it is endothermic reaction, and delta H will be negative when it is exothermic reaction. Okay, so as we know now what is the meaning of enthalpy. It is basically the energy stored within the system that is available for conversion into heat. So now we will see mathematically how enthalpy change is denoted, and sometime question is coming that derive, here it is coming question, derive delta H is equal to delta U plus P delta B. So at that time we need to derive it mathematically, this equation. Okay, this is enthalpy change equation. So once again, what is enthalpy change? It is the sum of, I can say, sum of internal energies. Internal energy is the sum of all the stored energy, all type of energy, but enthalpy is the sum of internal energy change of system and pressure, volume, work done. When pressure, volume, work done, at that time it is the sum of the internal energy change of the system. It is a state function, it is not a path function. It is mathematically defined as H is equal to U plus PV, which become in change delta H is equal to delta U plus P delta V, where P is constant. Okay, so now we need to derive it mathematically. So write at initial state enthalpy is, before going to change the energy, enthalpy is H1 is equal to U1 plus PV1 at constant pressure, and at final state enthalpy it is H2 is equal to U2 plus PV2. This is equation 1, this is equation 2. Okay, now change in enthalpy. How much change enthalpy, how much change is there in system by system, how much change in there in enthalpy by system? That is H2 minus H1 is equal to U2 plus PV2 minus U1 plus PV1. Now mathematically you know very well H2 minus H1 is delta H, which is there U2 minus U1, because minus plus minus, plus P is constant, B2 minus B1. Once again, how we can derive this equation? So you will start from the at initial state of enthalpy. Mean initial state enthalpy is H1 and U1 plus PV1. यहाँ कोई भी वैल्यू हो सकती है. At final state enthalpy is H2 is equal to U2 plus PV2. Now we are going to find out change. Very simple. It is final minus initial. Final state minus initial state. So H2 minus H1 is delta H. Similar way, delta H is equal to U2 minus U1 is delta U plus P. V2 minus B1 is delta B. So in this way we can derive the equation that delta H is equal to delta U plus P delta V. So hence proved. You will write here hence proved equation 1, that delta H is equal to delta U plus P delta V. Okay, and in enthalpy change of a system, it is equal to the heat absorbed or evolved by the system. Okay, enthalpy change is the system where enthalpy is either absorbed by the system or evolved by the system. या तो system energy absorb करेगा, जैसे ठंड में हम हीटर के पास बैठते हैं तो हम लोग अपनी बॉडी को गर्म करते हैं from external heat. Okay, this is a case of winter. Suppose at winter we are absorbing heat from the heater, but in summer we are sitting under the fan, we are releasing the heat to the surrounding. This is the case of summer. Okay, so system is either absorbing heat or either evolving heat. It means that we know that now we need to find, we know that now next that we need to find out that how delta HP is, delta H is QP. This we are going to derive how delta QP is equal to delta H. Okay, this I am going to derive. This is very important. So we know that delta U is equal to Q minus P delta B, because delta U is equal to Q plus W, but here we can write delta U is equal to Q minus P delta B. So Q become is equal to delta U plus P delta B. Okay, at constant volume, you know very well then delta B is equal to 0 and QV is equal to delta U now, because Q is equal to delta U plus P delta B. P delta B is 0, so it become QB is equal to delta U. Yes, QV is delta U. In this case, QV is delta. So hence it proved that the QV is equal to delta U. Sorry, QV is equal to delta U. This is we proved that at constant volume, when volume is 0, so QV is only internal energy. QV is only because of internal energy. It is not from external energy. So that's why it is only delta U. Okay, what if we take a process which is carried out by at constant pressure, which is carried out at constant pressure, at that time the work is going to be expansion. Work is done by expansion, mean volume will increase. जैसे हम कोई लोहे की अगर बॉल को हम हीट करेंगे, दिस इज जैसे हम टायर के रिम को हीट करते हैं. इफ सपोज वी विल हीट अप द रिम ऑफ टायर, okay, what will happen? The rim of tire is going to be expand. Okay, it increase the volume. It means that it increase the volume. After heating, when volume is increased, pressure is remain constant. At that stage, W is equal to minus P delta B. Mean W is minus P delta B, where V is increased in volume and pressure remain constant. In this case, volume increased but pressure remain constant. Hope so understand this topic, this example. So according to first law of thermodynamic, Q is equal to delta U minus W at this stage, not plus W. Okay, first law of thermodynamic, we studied that Q is equal to W delta U plus W, but in case of expansion, work done is negative minus W. So QP is equal to delta U. So where Q is heat absorbed by the system and delta U is increase in internal energy of system and W is work done by the system. When work done by the system, then delta W is minus. This we have already done. So according to this equation, then we will write QP is equal to delta U plus P delta B. QP is equal to delta U plus P delta V, and we know that delta H is equal to delta U plus P delta B. Okay, so in place of this we can write QP is equal to delta H, because in place of this we are writing now delta H. So hence it proved that QP is equal to WH, as we were from where we are writing QP is equal to delta H. So now this QP is equal to delta H or CP is equal to delta H. In case of heat capacity, we will write in place of QP CP. In place of QB, we will write CB. So now I think you got that how CB is delta U and how CP is delta H. Okay. So this is the basic numerical or basic derivation that you need to derive today. So today's topic was enthalpy change. Hope so you understood, and you will perform the same activity at your home in the same way. Okay. So today we did, let's conclude. We did once again, let me take, we did zeroth law revision, first law of thermodynamic. We proved that how delta U is equal to Q plus W, where expansion is there, where by the system heat is released, then minus W. Okay, so what is the heat capacity, molar heat capacity, relation between Cp and Cb? Cp is equal to Cb minus N, Cp minus Cb is equal to R. This is the relation we found, from where you were little bit getting confused, that is how delta QB is delta U, how QP is delta H. That we derived with enthalpy change. We derived that QB is equal to delta U and CP is equal to delta H or CB is equal to delta U. That will be proved here with enthalpy. So enthalpy is a topic that we have started, and we proved that delta H is equal to delta U minus P delta B also. So today's topic was very important. So please do study at home and take care until my next video will not be sent to you. So hope so you all are enjoying these digital classes. So thank you. Have a nice day.